sometimes you're given the percentage under the curve and asked to find either the z-score or the x value. In this example, it says determine the z-score for each situation. The first situation says 62% of the data is to the left of the z-score. Let's start off with our bell curve. There's our mean. Now we know that our bell curve is symmetrical, which means 50% is on this side, 50% is on this side. In order to have 62% on the left side, we would need to be bigger than 50. So we're looking at something possibly over here. We are looking at to the left, so we are looking at that, with this being 62%. Now, because this is a z-score that we're looking at, we know that the mean is 0 and the standard deviation is equal to 1. So as we go to look at this, the other thing we know is that the area is equal to 62%. And if we use that as a decimal, take this number, divide it by 100, we get 0.62. We are going to use what's called inverse norm on your calculator to figure out what that value is. Our inverse norm is the area as a decimal, the mean, and then the standard deviation. So if we go to do it for this question, we're looking at inverse norm. Area is 0.62. Mean is 0. Standard deviation is 1. And now at this point, just like in our normal CDF, this is our work. So this is the stuff that you do need to show as your work. Now that we have the work done on our paper, we can go to our calculator. So for our calculator, the normal inverse norm is in the second var section, and it is option number 3. So we're going to go down to number 3 and hit enter. We are going to put our area in, our mean in, and our standard deviation. In this case, the area was 0.62. Our mean was 0. Our standard deviation was 1. Down to paste, hit enter. Hit enter on the calculating screen. And we get a value of 0.30548, and the number keeps going. Because z-scores go to 2 decimal places, we will always write them to 2 decimal places. So in this case, it would be 0.3, and then after the 0 comes a 5. That 5 says that the 0 has to go up. So it would be 3.1. And there's our z-score. Our next situation says that 15% of the data is to the right of the z-score. So if we draw our bell curve, to the right would be going this direction. We only want 15%. Here's our mean. So 15% is going to be somewhere over here. There's our shading to the right. So there's the 15%. Okay, because it is a z-score that we're looking for, we know that the mean is 0 and the standard deviation is equal to 1. So we know those pieces. Now, one of the things that is required for us to be able to calculate the inverse norm is we need the area to the left of what we are looking for, not to the right. So in this case, we have this. Now we need to know what this value is. So as we look at our area is going to be 100% minus the 15% that we know, which will give us 85% as a percentage, and we can divide it by 100 and we would get 0.85 as a decimal. So that is what we're going to need to use in our inverse norm, not the 15. So as we go to do this, we are now looking at inverse norm. the area to the left, which we figured out was 0.85. Then we need our mean, which was 0, and our standard deviation, which is 1. At this stage now, we're going to go to our calculator. We're going to go second vars down to inverse norm and start filling in our values. So this time our area was 0.85, mean was 0, standard deviation was 1, hit enter on paste, and on the calculator screen we're going to hit enter again. And as we go to do that, we get a z-score value of 1.036433. Remember, z-score values get rounded to 2 decimal places, so after the 3 comes the 6, so that 3 is going to become a 4. So we have z is equal to 1.04. Athletes should replace their running shoes before the shoes lose their ability to absorb shock. Running shoes lose their shock absorption after a mean distance of 640 kilometers with a standard deviation of 160 kilometers. Zach is an elite runner and wants to replace his shoes at a distance when only 25% of the people would replace their shoes. What distance should he replace his shoes? So let's start off with our bell curve. And we know the mean goes in the middle. So let's go through and see if we can find our mean. We have a mean distance of 640 kilometers. We know this is 640. We have a standard deviation of 160. Zach wants to replace his shoes at a distance when only 25% of the people would replace them. Now, 25% of the people would be the first people to replace their shoes, not the last people. This would be the last people that are going to replace their shoes. This would be the first people to replace their shoes. So he's looking at something in here as our 25%. So as we go to look at this question, we know that our mean is equal to 640. Our standard deviation is equal to 160. We know our area is equal to 25%. And as a decimal, if we divide it by 100, we get 0.25. So we can go and we can use our inverse norm to find out what this x value here, we want to know what that distance is. So this time we're looking for an x value to calculate it. So we have our inverse norm. The area is 0.25. The mean was 640 and the standard deviation was 160. So now that we have our work done on our piece of paper, we can go to our calculator, and to find the inverse norm on our calculator, we're going to go second vars, and it is the third option. So this time our area was 0.25. Our mean is no longer 0. Our mean is now 640, and our standard deviation is 160. We'll go down to paste, and on our calculator screen we're going to hit enter. So we're looking at an answer of 532.0816. So here we get x is equal to 532 kilometers. Now this is a word problem, so we can write ourselves a sentence, and our sentence would be Zach should replace his shoes after 532 kilometers.